So let me start by telling you why IBM should join OpenHPC. No. I will talk a little bit about OpenHPC, but that was just a joke. So when you're a speaker in the second afternoon of the user forum, and I'm always impressed by the speakers, the industry speakers, the application speakers, everybody. The depth of knowledge, the breadth of knowledge is just tremendous. But when you're in the afternoon of the second day, you've heard a lot already. So you can probably tell from the title of my presentation, I'm going to take a little higher level and a little more light-hearted view of HPC software. And I actually have worked on CFT. That's how long I've been in the industry. I actually do work now with GenZ. I haven't talked to HAL yet, but I'm hoping to. And if we can make the video work, you'll get to see HAL a little bit towards the end of the presentation. What I'm going to do, though, is I'm going to walk through a little bit of my own experience, some of my own experiences in technologies, a little bit of HPEs, but I am going to end up on three serious topics. And three serious questions that I think will be controversial that I'd like to put out for you for discussion. So these are my three main topics. System complexity. I actually think I'm going to skip over most of that. Yunho and others talked and summarized all of this, and I hope you'll agree with my premise, and you'll see this, is that systems are getting much, much more complex at every level and will continue to do so, and that influences how we're going to have to manage them and the software environments that we will run on them. One company's continuing journey. I do want to make some observations about HPE, not so much about the product set, but about, I think, how our focus has changed on what we think we need to do in regards to HPC software. OpenHPC is one of those things. And then I want to talk about three needed solutions or implementations and invite discussion on that. So a few things about me. My experience, so full disclosure, so you can know whether what I'm telling you has any bearing or not. My experience includes all of these companies. My time in HPC started in Cray Research Incorporated. I actually got to work with Seymour a few times. Now, I was a software guy, so Seymour didn't really want to talk to me all that much, but I did get to work with him a few times. And it includes all these companies. Currently, I work for HPE. Now, here's one conclusion that we should make about the industry. Only HPE still exists. Of all those companies I worked for, and met wonderfully smart people with great technologies in every one of those companies. But only HPE exists. The SGI acquisition, as Bill Manell said yesterday, is almost complete, not quite outside the United States. Just in case you want to know, what's my worst prediction? A great conversation. I don't know why I remember this. I should forget this immediately. My worst prediction was a conversation with a good friend of mine, Katsuya Nishi, who now runs HPC Wire in Japan, about the future of operating systems, and was this new thing called Linux going to be any good? And my answer was, who needs another operating system? Well, okay, you should write off the rest of the presentation then, because my response into what the future of Linux was going to be was about 180 degrees wrong. Because I think virtually all of our systems and many, many other things in the world run on Linux. So that was probably my worst prediction ever. My best predictions, of course, are going to be what I'm going to tell you at the end of the presentation, which is why you should listen to all the rest of this. So let me go on to this for just a minute. So in the beginning, in Cray Research, it was all so simple. Now this is slightly false advertising. Anybody recognize this? Yeah, it would be easier if I turned it like this. Some of you, how many of you actually worked on one of these or used one of these? Okay, a few of you. Okay, this is a Cray 2 module. I couldn't find my Cray 1 module. I have one somewhere. I think I lent it to someone. Yeah, you can tell it's a Cray 2 module because they sandwiched circuit boards in devices, one on top of the other with mechanical vias. And the only way you could cool this is with liquid immersion technology, which is what the Cray 2 was. So, Jan, you're sitting in the back of the room. I implicitly trust everyone in this room, but I really don't want this to become part of anybody else's museum, so I'll send it through the room. We'll have show and tell. You can see a Cray 2 module. I should have a Cray 1 module because the point I want to make is in the beginning it was really simple. How many processors in a Cray 1? One. It was a pipeline vector processor, but there was only one. And then when you look at the HPC software environment that ran on a Cray 1, it was really simple. The operating system came from Cray. CFT came from Cray. Most of the runtime and development libraries came from Cray. The management software came from Cray. It wasn't quite that simple. There were scientific libraries, applications, of course, that came from other sources. But everything came from Cray. It was and from Cray Research. It was quite simple. It's clearly gotten much more complex. And I'm going to skip over most of the rest of this because I think these points have been made well by other presenters. The types of computing units that we have nowadays are getting more and more complex. I was reading about Google Tensor Processing Unit, a custom ASIC implementation. And I think Ron from SDSC talked about FPGAs that were customized for life science applications. So we're seeing all of these types of computation, and we're seeing them all in the same system. We've talked about the price of computing going down. What I was going to focus on here is that individual gates and transistors get cheaper. The prices, of course, go down. The fact that computing is really dominated now by the cost of moving data. We've discovered that. And Thomas Stirling, one of the people I love to quote, who's unfortunately not here, will be at ISC, summarized all this. I won't read this in the interest of time. But he basically said, cores are so cheap, we should be putting them everywhere. We are. We're putting them in the fabric. I heard a discussion where we're putting them in the fabric. And in fact, we have lots of issues with memory and storage hierarchies, which we have to deal with. We talked here about the growth of data volumes and the types of data we deal with. We talked about the changing memory and storage hierarchy. So other presenters have made all these points. I hope you'll just accept, therefore, my premise is that as we see, system complexity and scale are continuing to grow. They're pretty much growing unbounded. They're really only bound by our ability to feed and clothe them. You know, how much power, cooling, and floor space we have. And I would put out for your consideration, and I'll come back to this at the end of the presentation, that their complexity is growing possibly beyond our bounds to actually manage them. I'll come back to that at the end. So let me talk a little bit about, I really don't want to dwell on HPE product, but let me just talk a little bit about the journey of the company. Over on the left there, you see the original logo from 1939 when HP was formed. And the company that I'm now a part of is HP Enterprise. You're frowning, Rich.
What did they make back then?
That's a good question, but you can find it in Wikipedia. For those of you that have been in the industry for a while, you know at one time HPE had a world-class HPC software environment. And I came across this document, and I'm sure you can't read this beyond the front row, but this is the MPI User's Guide for HP MPI that at the time belonged to HP. It went on to belong to Platform Computing and then to IBM. And I was interested in the revision history, that the first revision was 1997. So HP then created an MPI at about the dawn of clusters. So they were there at the beginning. I was not part of the company at that time. This was the 8th edition in 2003. So, and HP had this full set of software to run HPC environments. I would say then the company lost its way. In 2001, it became a personal computer and consumer electronics company when it acquired Compaq for $25 billion, which was the, I think, most expensive tech acquisition at the time that had ever been done. And then 10 years later, a different CEO decided that they wanted HP to become a software company, Leo Apotheker, and spent $11 billion on autonomy. So by the way, both of those efforts have now been spun off into other companies. So HP, in a way, has gone back in HP Enterprise into something that was more like what HP originally was. I hope you think we're more on track in a more recent acquisition. A year ago, November, HPE acquired SGI. Bill Manel talked about that yesterday. And that allows this. And I don't want to dwell, there's a lot of stuff in here, but HPE then has gone back to create an entire HPC software environment, top to bottom. Now, this isn't all of our software, and you see some of our strategy embodied in this in the bottom, that some of this is HPE developed, some of this is open source, some of it is third parties. But all of the components that SGI was selling, as well as the components that HPE produced, are being provided now, or will be provided very shortly by HPE. And I don't think I need to dwell on this, but the top-level elements of our strategy, and you've seen this embodied in things from the Exascale Compute Project and others. Resiliency and security, end-to-end security, very important. Ease of use, including interoperability. Scale and performance, of course, because that's the business that we're in HPC. So here's a slide that Bob made me put in. No, that's not really true. I think what's different about HP's strategy now in HPC is that we're not just about our own software and our own technology. We are platinum members of OpenHPC, as I said this morning. We build on top of OpenHPC, and we think that having a common software base, common APIs, a portable application interface, so that applications can be ported by users into different environments is good for the community as a whole. So we are members and we contribute to OpenHPC as a whole. So here I got to GenZ finally from CFT. GenZ is technology that came out of Hewlett-Packard Labs, but rather than, and we are implementing the technology, of course, but rather than solely implement the technology as a proprietary technology, the first thing we do was to create an industry consortium to share the technology and hopefully promote the technology and what it provides over what we see as some of the problems with current memory cache storage infrastructures. So I think you can see hopefully that we're moving a great deal from just having our own software environments to actually making leadership contributions to the industry as a whole. HP Labs is still part of HPE, and there's other things like Redfish that was a spec written by HP that is now open. And I think I'll skip this. So let me get then to the core of the presentation, my 10 minutes. I mean, we might even make it through the film clips. There are three things I'd like to point out and really for discussion. I don't think one of them is very controversial, but two might be. This is a slide from Greg Kurtzer, and a tip of the hat to Greg and LBL for their work on singularity. I've spent a large portion of my career in HPC and talking to people about HPC software environments about whether virtualization, and it says ESXi here, and I'm not trying to point out VMware, I'm trying to point out virtualization in general, about whether we wanted to pay the abstraction penalty to virtualize HPC applications. And it's been a long-running discussion, probably 20 years. My take, and I'm not the only one, but I think our take is that that time is over. That this has been discussed many times in this room today, that, let's see, I'll go on here. I really want to focus on singularity, but our take is flexibility wins. And flexibility is not the right word here. I tried to reduce it to one word. It's oversimplified. But for most customers, and there will be exceptions, there will still be dedicated systems where every iota of performance is the most important thing. But for most HPC customers, for the broad market, flexibility will win. The decreasing cost of computation, the declining abstraction penalty, instructions that are implemented in silicon, as well as just better models, and the increasing variety and complexity of workloads, plus just the need to do more with less, the real world, limited budgets, and to do more and be able to repurpose resources quickly will win. That's what we think. So we're going to see containers. We have great hopes for Singularity. We think Singularity might be that container in HPC that will serve the users well. We see HPC as a service flexible capacity as being important. Not everybody wants to go off-premise, so having flexible capacity on your site that you can use on-premise we think will be important. We also think HPC cloud, hybrid HPC cloud will be important. And we actually don't see so much security being a barrier to HPC hybrid cloud. What we see being a barrier to HPC hybrid cloud is data movement. Is large-scale data movement of simulations to sensors and the like, and that will continue to be an issue for some. I put this in here because I believe in this. This is something I worked on a long time ago. And I'm out of my domain here now. I'm the cooling guy again, the guy that only knows cooling. Because this is really a hardware issue, not a software issue. But it feeds downstream the software systems that have to manage components. A long, long time ago, the late 1990s, when I was at Sun Microsystems, I worked on something called Genie. And does anybody know Genie? Does anybody remember this technology? A few of you do. Genie was, and this was like a lot of things in Sun Microsystems, Genie was IoT ahead of its time, about 15 years ahead of its time. It was embedding hardware Java engines in devices that could then self-identify and self-maintain themselves so that they could gather together in a network and they didn't need us. They could talk to each other. And when I say self-maintenance, I should probably specify. In this case, I think we HPE, IBM, Dell, every manufacturer, we have immense systems for managing low-level maintenance, low-level BIOS, firmware. Do the drivers match? Do the drivers match the operating system? Do all the systems in a cluster have the same image? We have immense tools for doing that. And my question is, why do we have to do that? We have the technology, and we have developing technology now in IoT that we need some of the IoT technology inside exascale systems that allow components to be self-identifying and align their configurations themselves. We can do this. We already have the technology to do this. We either just don't want to pay for it on a customer basis, or we don't want to build it into the system. Oh, we got to HAL. Everybody knows HAL, right? So who quoted Forbidden Planet yesterday? Somebody quoted Forbidden Planet. Yeah, my second favorite science fiction movie. So you're going to have to bear with me for a minute. This is hopefully the most important part of the presentation, but I have to escape. I have to escape out of here for a minute and go to here. Oops. Nope. What? For all the technology we have, we can't make the media work right.
Oh, did you need the sound hooked up too?
Oh, yes, we need sound. What's video without sound, Earl?
That was possibly missing there. Probably doesn't work well on the USB port.
Did you get it?
This was speaker out, he said. Yeah.
Got it?
So hopefully.
Just a moment. Just a moment. I've just picked up a fault in the AE35 unit. It's going to go 100% failure within 72 hours.
It's still within operational limits right now?
Yes, and it will stay that way until it fails.
Would you say we have a reliable 72 hours to failure?
Yes, that's a completely reliable figure.
A completely reliable figure. But I want to go back to what HAL was telling him. Isn't this what we want? So HAL was telling him that a unit was going to fail. It was going to fail in 72 hours. No one on the ship could predict that. HAL said it's going to fail in 72 hours. It's going to stay in operational limits until it fails. And then they concoct a plan to go fix it. So isn't this what we want? This is what we want our systems to do. This is actually what we need exascale systems to do, to tell us what will fail. And there's been discussions here about forensics and resiliency and predictive analysis. This is what we want to happen. So let me see if I can get out of here. I'm going to do this a little bit out of order. But I'm going to tell you, as you know, how many people know the movie? Everybody knows the movie? Everybody knows the movie? So we know that this is what we want HAL to do, but we have to be careful.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
Ah, that simulation you wanted me to run on that gas turbine? I'm sorry, that's a little bit too important. I can't be interrupted right now. So we have to be very careful as to what we tell our systems to do. Now, let me go back just for a minute to the PowerPoint. So somebody already charted a path to this. And I'm going to give our friends from IBM credit. So when I started researching some of this technology, there's a thing called autonomic computing. And this paper, you can go find this. You can just Google this. Google autonomic computing. As was pointed out, it's not called autonomic computing anymore, although a lot of the technology exists in IBM. This paper is from 2005. And here's a bunch of the tenets that IBM set out for autonomic computing and said systems need to know themselves in terms of what resources they have access to. They need to automatically configure and reconfigure. They need to optimize their performance. They need to repair themselves. In the interest of time, I won't go through all of this. But you can find this. You can read it. So then your next question should be, well, if this came out in 2005, then how come we, and it's so important, why haven't we done it? And I would say, my opinion, our systems weren't of the scale yet that we actually needed this to succeed. And number two, we didn't have the technology to implement it well. Today, we have the technology. We can do this. I believe we can do this today. And I'm going to add something that my boss said the other day. When Bill Manell was talking, he said, we need exascale systems to do AI, deep learning, and IoT. I agree, but I would say, and what I'm trying to convince you of is, we need AI, deep learning, and IoT technologies inside exascale systems. My belief is that, and again, I'm not the only one, that our systems are becoming so complex, but that by the time we get to exascale, we will need autonomous learning. We will need autonomic computing to manage them. We will need systems that learn autonomously, that figure out how to maintain themselves, how to upgrade themselves, how to optimize themselves based on changing conditions. This will get me in trouble with lots of people. If you're a system administrator, your time is limited. We need system mentors. We need people that give rules to the systems and have the systems learn themselves. We will not be able to keep up with the manual interventions that the systems will require. We don't want manual interventions. And we need to be comfortable with relinquishing a certain amount of control to the systems. So let me summarize and show you one more video clip then. And hopefully there'll be time for a few questions. So we're continuing as a company to expand our capability and provide complete HPE solutions. A part of that was the acquisition of SGI, but we're really moving from that now to focus on contributions to the industry as a whole and leadership. But the 3 points I want to leave you with for discussion, and I'd be glad to discuss this with any of you, is putting IoT concepts in self-identifying and self-maintained components amongst all manufacturers so that systems are more easily maintainable. That containers, HPC as a service, and hybrid cloud are going to be they're going to be de rigueur, they're going to be standard operating procedure for most sites. And lastly, we need systems that learn and operate autonomously to operate at exascale. And if I have just one more minute, let me show you the last video clip. So Joe from GE yesterday, your very last slide, you said, you guys, us guys, we all have superpowers. We're supermen. We have superpowers at our disposal. I want to leave you with a complimentary message.
How would you account for this discrepancy between you and the Twin 9000?
Well, I don't think there is any question about it. It can only be attributable to human error. This sort of thing has cropped up before, and it has always been due to human error.
So autonomous systems, but with care. Thank you very much.